Hello and welcome everybody, and welcome to the next round of the visualization workshop series. Today we're going to be looking at a more climate perspective on storytelling. We won't be leaving weather behind. We've got some weather perspectives in there as well. Just to remind a couple of things, as we also let people just get back to their desks if they're in an office environment, find the invitation, open it up and join the webinar. We will be taking questions using the Slido tool. So if you go to slido.com and the hashtag is EODataVis, and we'll be posting that in the chat in a moment as well. So you'll have the link across to there. Do feel free to ask as many questions as you like. We'll get to as many of them as you can. And you also have the opportunity to upvote questions that you're particularly interested in. My name is Mark Higgins. I look after training, partnerships and evaluation on the user side here at EUMETSAT. We're based in Germany and we're Europe's weather satellite provider. You're going to be hearing from people in the satellite perspective and wider today, which I am particularly pleased with. What I will do is just show you the agenda so we can follow the set of talks that we've got today. So we'll be starting with storytelling from climate and weather data from Scott Duncan, who's an operational meteorologist, senior meteorologist working for a whole range of areas. He works currently for EDF Energy, but was working previously for a couple of other commercial providers and was involved in a very popular tool called WX Charts for looking at weather data. Samantha Burgess, who's part of the climate change service. And these two in particular are going to give us a broader perspective of the storytelling. And then we get a little bit more practical. So Chris Stewart will be talking about how we can actually access and visualize some of the data provided by the Climate Change Service. And then we'll, after the break, the question and answer session, we'll then get into impactful communication with Clare Nullis, who's the WMO Media Officer, more practical examples with Tony Vecoli from MEEO, who's a remote sensing organisation. And we'll wrap up with one of the EUMETSAT weather experts, Ivan Smiljanic. But to start with, let's turn over to you, Scott. Welcome.
Thank you very much. Thanks for having me.
And it's a great joy to have you here. Most of us, or many of us who know you, will know you from your storytelling on Twitter. And so it's really nice to hear from you a little bit more now. Over to you, please.
Thank you. Let me just share my screen and get the presentation running. There we go. Hopefully you can all see that. So yeah, thanks very much.
Perfect.
Mark and the rest for having me on today, and just giving a little bit of background to, well, getting from Copernicus data or other geospatial data and then turning it into something engaging and then putting it out on social media, as Mark kindly already mentioned. That's somewhere where maybe quite a few people have already seen some of the things that have gone out before. So today it's just quite a quick piece from me. Just a little bit of background. So as Mark also mentioned, I had a little bit of experience with doing kind of data visualization through a website called WX Charts with a good friend and colleague, Dan Harding. That's now been moved on, but I've also taken that kind of skill set and then put it more into the kind of weather and climate communication part, and that's now mostly on kind of Twitter, Instagram, Facebook, so social medias really. But in my real job, I am an operational weather forecaster, so being part of the data, kind of intraday, day ahead, all the way through the next couple of weeks, month ahead, that sort of stuff. That's kind of my area of expertise. But the social media part and kind of communicating of weather and climate is a big passion of mine. So I'll be talking quickly about the data I'm using, how I access it, kind of a key line of operations to creating the maps. Very briefly, this will be talked about later by Chris. Then social media, some experiences with that, some things that have worked for me and things that really kind of get people hooked and involved and talking about weather and climate, but also then some of the challenges that we face, and people probably might start thinking of things like trolls and all sorts of things on the headlines that are appearing in the news now. So there is definitely challenges within this kind of aspect of weather data viz, because almost everyone has an opinion now, especially on social media. And then just quickly summarizing that at the end with some key takeaways. So my data use and access, let's just start with an example of Copernicus data, so kind of climate data. starting with some of the very clever APIs. I then use that with Python and basically grab some netcdf files. This will be talked about in more detail later. Get a gridded format of this data, for example, netcdf, or if it's like operational weather data, it might be in a GRIB format. Again, this will be talked about in more detail later. I then use a platform called Jupyter Notebooks to basically order some Python scripts to execute the visualization part. This is kind of where the magic happens. It kind of brings the data to life, and it eventually spits out these kind of maps or multiple maps, so then you can have looped them into some sort of animation. So it's quite a simple process to get from data source to map. And I think one of the simplest parts is actually kind of just even getting the data in the first step. It's the kind of the Jupyter step, where you've got the kind of design and then animation, which maybe is a bit more involved and to your preference. So that's the kind of key operations in that. So in social media, I was thinking, well, let's just start with a few examples. I'm Twitter, Instagram, Facebook. I know there's many different social media platforms out there, some that are growing quite rapidly. There's other big ones like TikTok. I've just never found the time to jump in on these platforms just yet. Just managing these three is plentiful in terms of how much time it takes up. But I thought, let's just start with a few examples of what works, in my opinion, because data itself can be beautiful, and I think representing it in the correct way, you can really strike a strong message and get people really resonating with the message. So let's start with an example of a tweet I put out in March 2023. It was a very impressive month. It was the second warmest March on record in the Copernicus data set there, and obviously more likely for a longer period as well. You had some very contrasting extremes, some very strong cold in Canada, Northwest US, but also obviously very significant heat covering large portions of the Northern Hemisphere, all the way from North Africa to Asia, but also down in South America. And throughout that whole month, I was following these extremes kind of almost on a daily basis, like heat records getting broken here and there. So then tying this all together in some sort of thread, starting with a global perspective, and then starting to kind of hammer into kind of more localized parts of the world to really bring out those extremes and what will get people talking. So basically starting off with this global perspective, but then kind of hammering down into something more local. So in that thread, you could then follow it, zooming in on that cold blob in North America, and then kind of the European sector as well. So people can really start to dive into the data, because the data itself is very impressive. It's a nice resolution. It really kind of gives you nice maps. And I think kind of zooming into these extremes really lets people share the story that they want to tell, because the data really is telling the story. So having not just a global perspective, creating a thread and kind of zooming in with very limited annotations, just letting the data speak for itself, just quite minimal captions, I thought worked really well, especially the way people use social media. Kind of simplicity really is key. And this is going to be quite a recurring theme into kind of what I think works well on social media. Also, the wording I think is crucial. It's obviously kind of focusing on the big picture. It's starting with the headline, it's second warmest March on record. That's straight in there in the first sentence. But also there's a sentence there, it wasn't warm for everyone though. Because obviously if you lived in Canada and you saw second warmest March on record, that doesn't really kind of ring true for you in your particular location. So having that, I think, is quite important. And that kind of entices people that might also, I guess, be a little bit more skeptical, or people are kind of still learning about the data, that, you know, it's warm across the world if you took it as a global perspective, but you still get these cold extremes embedded in this. So I think having that as a hook will get people going into the thread itself. So people that did see the kind of cold extremes in Canada, they would be able to relate to it even in that first tweet, even though obviously the headline is on the warm side. So I think that works really well. Kind of key takeaways so far, very simple, letting the data speak for itself, but then kind of hammering in to these more localized parts of the world to kind of really bring out those extremes, which gets people talking. Other versions of tweets or Instagram posts or Facebook, all the like, I think that works well is kind of putting your ear to the ground and listening to what gets people talking. So 1936, or the Dust Bowl years of North America, were very, very hot. It was kind of exacerbated by poor farming practices, but it was very, very hot, and statistically still stands out as, you know, one of the hottest periods in North American history and across the US. So people like to go back to the Dust Bowl days and say, well, we've had extreme heat recently, but it doesn't really compare to that, even though there's definitely tangents you can't really draw between the two when it comes to the type of droughts that were in place back then. And I think you got to be cautious when you kind of pick cherries, but using your kind of ear to the ground method and kind of looking at what people are talking about in your comments, you can actually answer those, and you'll notice that people really do respond to these quite well. I think, for example, 1936 saying, okay, it was super hot in North America, and you can see it from this map. This is actually using NASA GISTEMP data, but same sort of idea. And then comparing it to summer 2021, so you could say, yeah, it was super hot in 1936, but you can zoom out and look at the rest of the globe, and within that thread, then perhaps add a couple of graphs or even animations looping through all the summers to show how things have changed. So you're kind of taking that heat record or these extremes on a kind of continental or regional scale and then zooming out. And people really interact with these type of comparisons super well, I think, and people can really see what's going on. And it kind of takes out that kind of cherry picking perspective if you can then really explain it quite well in a thread. And again, very simple. Left you have this, right you have that. There's another example. In Northwest Europe, we had a super warm summer, 1976. A lot of people here in the UK will remember that very well. And doing the same sort of thing again. Last year was particularly impressive with the summer heat that was building out of the Med through a lot of Central Western Europe was shattering records, and that happened well throughout summer. We won't forget our 40-degree day very quickly in the UK, for example. But doing the same sort of thing with Northwest Europe and saying, okay, it was super hot, and for its period in history, 1976, June, UK, Northwest Europe, France, Spain, super impressive heat. But then zooming out and looking at the rest of the world, the data completely speaks for itself. And that particular graphic was shared tens of thousands of times and also taken by news platforms. And quickly, it kind of stamps out these kind of, not trolls, but people that kind of remember extremes in the past and then kind of maybe downplay a bigger picture. So I think these sort of things can be very powerful. Again, caveats, it's very important to kind of link it into the actual trend. So you're not just comparing 2 years. If you go into these threads, we'll often kind of link in climate trends for either individual countries. There's other data sets I like using, or even just using an animation of maps of individual months, kind of going from the start of recorded observation and all the way to the present day. So I think these things work really, really well. Again, very simple. The maps don't really have annotations on them. You can see just a small circle in and around Northwest Europe. Very minimal. The data really does speak for itself. So simple comparisons, and I think that works really well on social media. So experience and challenges. I thought that a good way of kind of putting almost the pros and cons to kind of social media data and communicating on social media. So simplicity is key. So that was the main thing. What I've just kind of talked about there is almost no labels required on a kind of well-designed graphic. I think can do very, very well, because if the color scale and the map is in a nice projection, it really does show things very well. So having lots of labels and stuff like that can make it a little bit less clear. Very simple arrows or circles, I think, can also work quite well. So simplicity is obviously quite a big headline there. And that kind of rings out the first point. They're clear graphics, very basic annotations. That's same sort of thing. Simplicity is really the kind of key thing. Jargon and text volume, obviously you're kind of limited on many social platforms when it comes to actually communicating. So kind of short threads get people scrolling through that and kind of following the journey of the data. I think that kind of works really well. And again, it's more the graphs that are doing the talking, just very kind of key headlines, because what people will remember and see and what they have time for on social media might be very limited. So just keeping it as these key headlines is obviously, in my opinion, the best way forward, and text volume kind of at the limited side as well. So creating threads and linking in the work of others, I think this works really, really well, because social media is full of wonderful people sharing excellent work, and you can really kind of tag them, link in their posts, because it won't be just you that'll be looking at these extremes or kind of communicating these key events or climates or summaries of what's gone on recently. So creating your own threads, but then saying, look, this is what other scientists have said, and this is what they've found, and this is a graph that summarizes really nicely what I'm saying, and that kind of works in nicely with your own thread itself, and that then kind of broadens your horizon, and it also brings in other people. And I think that's a great way of kind of collaborating and kind of taking it to the next level. So yeah, definitely kind of linking in others that are also talking about it. Again, there's many people out there talking about it all over social media. Providing links, I think, is a really good one, because a lot of people just want to go into the data. Either they're skeptical, there's nothing wrong with skepticism, but a lot of people just like to go into the data themselves and actually see it. So kind of communicating either whether it's a heat record, like actually giving them the weather station where they can see it in a different format, or another thread where you've got maybe the official providers talking about the heat in their neck of the woods. I think that works really well. So links are very important where possible, just to give as much kind of background to what you're talking about. It just adds more meat to the bones, I think. Historical context is obviously really good when you're talking about a climate trend. That's really good. What I found when I started making these maps, I was talking about impressive heat in the Arctic. Quite a lot of people didn't know how hot it got there, for example. And I've learned very quickly that it's great to show how these extremes may be changing, or kind of just put it into perspective, maybe even talk about a past event which was similar, but now, like, if you think about the bigger picture, things are changing. Just having some sort of historical context. Actually, a good example recently is the rainfall in Italy. We do get a lot of rainfall and extremes in Italy, and sometimes it's just harder to attribute it to climate change or climate signals, and just giving historical context can just limit either skepticism or some of the questions. So giving historical context where possible in most understandable ways, I think is quite a good idea. And that actually ties into one of the challenges, which I'm just about to mention. But some of the challenges, explaining complex terms, obviously being brief, that's the key in terms of the simplicity. But when you've got complex terms, putting them briefly, you can lose some of the important parts to that. So obviously kind of keeping the most important parts without kind of oversaturating the word count and letting people's eyes glaze over if they don't fully understand. That's obviously the key balance. The kind of less is more, but without removing the most important parts. There's a fine balance, and I think that sometimes can be one of the biggest challenges, is kind of communicating the key things without losing, the most important parts of the science. Communicating uncertainty, that kind of ties into what I just mentioned there about kind of either attribution to climate change or even what's happened in some places in the past. Sometimes there's limited data sets, for example. Communicating uncertainty can be quite difficult. That actually is more for forecasting itself. I don't actually talk about forecasts in the stuff I do on social media. I normally talk about what's happened in the past, but obviously forecasts, the uncertainty is pretty difficult. And also if it's a forecast for an event that's never really happened before, like for example, the first time parts of Northwest Europe, the UK, hitting 40 degrees, that's a very big challenge because it's something that's never really kind of happened before. So you don't really have something to compare it directly to. So that sort of thing is difficult, and using the right words without, first of all, panicking, but also without downplaying. It's a fine balance, and I think that's quite a hard challenge. Attribution to climate change, that can be difficult in some extremes. Some are easier than others. There's fantastic accounts out there looking at the attribution to climate change, quite thorough, following through with weather events like that. So that's always a bit difficult. And also that becomes very political, climate change, very quickly. So you'll see if something does get more attention, you'll get some unsavory characters maybe coming up. And this takes me up to the trolls and bots. So regardless of what you say on social media, people have an opinion, and there's more and more people, I feel like, even in the last few months, maybe it's because of the change of ownership of some of these platforms, but there's certainly been a huge increase in trolls and bots, or accounts that perhaps could be posing as such. And I think when you get comments that are either unsavory, very unscientific, or perpetuating myths, or very easy to debunk kind of facts that they carried forward for the last few decades, it's very tempting to reply to these things. And I think it's best to completely avoid, because some of these platforms are becoming inundated with some of these comments, and they should just kind of fall to the bottom and just be ignored, in my opinion. But they are ringing louder. There are more of them, it seems, and that could be just my experience. But I've seen other scientists, communicators, also seeing similar trends in that aspect. So it's just something to bear in mind. That is a challenge. It can become very taxing mentally reading these, so it's best just not to even read them. But it's something that's definitely been on the uptick recently. So before wrapping up and passing on to the next speaker, Samantha, I'll just give you a quick summary of my main takeaways. So connection to geospatial data can be very easy. I think then telling the story with the data can be very powerful, and there's definitely a big space for that on social media. The reach you can get from tens of thousands to hundreds of thousands, or if it just hits the right weather and climate story in the right way, it can quickly become global news and reach millions of people. I've seen that countless times recently, and it's very kind of key facts that just do very well, because it's telling the story that people can share, and if it's topical in the news as well, that's what really kind of hits it running. So data visualization is very impactful on social media, and then that's often now where a lot of news sources get their information from. So just a quick quote there, and simple and clear go a long way. That was by John P. Cotter. So he was from Harvard Business School. And I think that really does ring through with some of these animations and visualizations. And I think playing around with it and seeing what people react to is quite a good way. And just seeing how simple things can be and how people can just get that main headline and then share it. That's what I think works really well. So that quote, I think, hits the nail on the head. Regional detail and extremes. Obviously, there when you zoom in and you've just got a one area that you wanted to talk about, putting that on a global picture and seeing how it compares to the rest of the world, I think people really like seeing their place on a map, and they're more likely to share it and say, look, there's my hometown or my home country. It was an extreme last month, and you can really see it versus the rest of the world. It really kind of gives a strong message. So I think using the data to do such is a really powerful tool. And then using these kind of comparisons or other clever techniques to kind of show how things are changing. And I'm sure there's other talkers here today who are going to share some other examples of kind of communicating and being creative with data. It can really go a long way. So yeah, finding hooks to join those that may be skeptical or those that have questions. So that's kind of using those cheat codes of there's an extreme cold in Canada, and then kind of then zooming out to the rest of the world. I think that's quite a powerful way of talking about an extreme cold, but also showing that it was the second warmest March on record. These sort of things can do very well. Or again, these examples, putting the ear to the ground and listening out to what people are talking about. People are always discussing the Dust Bowl days and the heat in North America. It's like, well, let's show that data and then stack it up and compare it to what we're looking at now, and just get people talking, because people will definitely add their own opinion when they see these type of things. I think these can work very well, and I think that takes me to the very end of my part of the presentation. So yeah, thanks again for having me on.
Thank you very much indeed, Scott. Thank you for joining us. I know you have to skip away because you've got another commitment in just a second, but I did have a couple of questions. So one from the Slido, someone was asking, what's the kind of difference you see in people's engagements with a post versus a thread?
I think posts, it's more kind of what click and done. It's very quick, and people, I think maybe it could be the algorithms actually within these platforms. It's what gets people kind of scrolling through them and linking through it. So then if people are kind of reading through it, clicking on images, zooming in and seeing things in different ways, and they're spending more time on it, I think a thread can tell you that story. I think you might actually be able to see that actually in, sadly, like tabloid news stories. You want to just find out when the rugby's on or a football game is on, but you've got to scroll all the way through it to kind of get to the main point. Yeah. It's this interaction and time spent on it. So if you can have many graphics showing kind of a monthly summary, I quite like doing this, because if you have it all in one with many images and lots of arrows and it's quite small, it doesn't tell the whole story. If you can get it and just kind of spread it out in kind of key summary takeaways, people will spend more time looking at it, and that might help. I'm speaking outside my comfort zone on how these algorithms work, but I think that could be quite important for people looking through these threads and engaging with them, like not just in one post, because if it just appears and there's nothing else for them to read, it might just kind of get pushed back in terms of importance. I'm not entirely sure, but I think it gets people reading through things in more detail and interacting with more posts within itself. And it's a good way, I think, of breaking up the information so people can actually digest it. So I think there's kind of two parts to that makes it better.
And you mentioned your comfort zone just then. I'm wondering, are there any stories that you don't go near because you are not comfortable engaging with that particular topic professionally? It's not something you know about, or things like that.
No, I quite like finding things that kind of get the people talking, like a cold extreme. I mean, that was one of the things that really got me interested in weather and climate growing up in the Highlands of Scotland. Love cold, love skiing, always looking out for the next snowstorm. Obviously, we're in the middle of summer in the Northern Hemisphere. But any cold extreme, I think, is absolutely fascinating, and got absolutely no hesitation to share how cold it was. I'm seeing very misleading headlines about how cold it was in Australia, and that might be my next post, is kind of using that extreme cold of the month of May. They've said it's the coldest May on record. It wasn't. It was the 17th coldest. But using that and then using the data, so maybe a misleading headline and going down that path. Obviously, careful, because it can attract maybe unsavory comments. I think it's more replying to these people. That's my comfort zone. I wouldn't want to speak to them and reply to them, because often it's so biased and non-scientific. So I think those are the things to avoid, in my opinion, rather than if there's a topic, if there's some things that are just not clear, then I wouldn't put a post about it. For example, I was actually asked to speak on a news channel about the rainfall in Italy, and they were asking how much is this climate change, and I said it's too early to say. Like, we get extremes in Italy. It's very big whiplash, for example, from drought to floods catastrophically, but the rain hasn't stopped falling. This is quite an extreme weather, but the seas aren't that warm. The atmosphere is not that warm actually relative to normal for this extreme. So it was, when it's not clear, I wouldn't talk about it. If somebody asked me to talk about it, I'd say it's not clear.
One last question, and it gets to the second comment there on the Slido about panic and the sort of the emotional temperature of storytelling. Because our stories about the Earth's environment aren't neutral. This is where we live. This is home. And we live in a changing climate. And the Paris Agreement is clear that this is not good. What's the role of sort of emotion and feeling? So, and that the line between being ambivalent and panic.
So I think from my purpose in kind of making these maps and what I'm trying to communicate here is literally what's happening, and putting it like as scientifically as possible, with historical context as clearly as possible, on a platform that can then share far and wide. I think keeping it purely scientific and just putting the stats, the data really tells powerful images and powerful messages. If I then say panic, for example, then it's a narrative, which it's a narrative to some people who are skeptical, who need to listen the most, will instantly slam the door shut on it because they'll see it like that. They won't even look at the data. So from this data side, I think, in my opinion, I think it's really important to just be very, very clear in the data and show what it's showing. And it tells such a powerful message and shows an incredible trend that we all need to act upon. But I think, yeah, I think it's a difficult one, because science and politics, to keep it crystal clear in a thread and be able to then be shared by many other people who then add to it as well. There's two parts to it, and I think doing all in one, it can lead to either confusion, or it might even not reach the right people. Yes, there's pros and cons, but that should be one of the challenges for sure.
Brilliant. Thank you so much indeed. The other questions in the Slido we will come on to, so do keep asking them. We can come back to later. Scott, I know you have to leave, so thank you so much for joining us now.
Thanks again.
And we turn over to Dr. Samatha Burgess, who is the Deputy Director of the Copernicus Climate Change Service. Sam, I'll let you explain what that is, but just as a bit of an introduction, C3S is fundamentally awesome and a wonderful thing to have in the world. Over to you.
I don't need to speak now. That's absolutely brilliant. And thank you so much to Scott. Yeah, there are so many messages that are identical to what he just shared, so I can perhaps skip through many of those. So thank you everyone that's here. My presentation is structured slightly differently. So I'm giving you my takeaways up first, and then I'm going to tell a personal story. And I think reflecting on Scott's answers, which I 100% agree with, I think it's also really important to understand your audience. So when it's social media, when things can be taken out of context, I agree 100%. You really need to focus on what the data can tell you. However, when you're speaking to people, I think it's really important to speak from the heart and show your passion, show your excitement for what the data is showing us, and how it impacts you, how it impacts the people in the world around you. So in terms of data viz, I think, you know, it's a really exciting moment in time, because our ability to map and visualize the data around us, we've never had more data than we have right now, and the Earth observation community is a huge part of that. So I've just got some quick takeaways here, and you can see many of these are very similar to Scott's. First and foremost, I think it's really important to understand the intent of what you're trying to show. So are you trying to show change? Are you trying to show extremes? Really understand what objective you're trying to get with the figure, and then or with the map, or whatever it may be. And I think it's really important to tell a story, you know, having these contrasts to really show people what your point is through the data that you're using. And for me, the whole point and the real excitement from data visualization is to start conversations, to have those random interactions with people that I have on an almost daily basis because they've been inspired or they're curious about one of the figures, the pictures that you've put out there in the world. I really liked Scott's other point of collaborate and show credit as well. Is a huge community of people working on data visualization, and there's space for everyone. So really, let's collaborate, let's work together, let's show the source of data or the source of the inspiration, but then you've taken it 1 or 10 steps further. And as Scott mentioned, simplify it as much as possible, because the simpler the figure is, the more it will land with people. Test it beforehand as often as possible, and animate as well. If you have the ability to do a GIF, particularly on social media, it really really helps. So now for my personal story. So some of you on the audience probably know me through social media and know my family. And we had a particular weekend back in August 2016, where very romantically my husband and I were building flat pack furniture. I think there wasn't space for both of us in the same room, so we were doing it in separate rooms. And we had the Olympics on in the background for vague entertainment. And suddenly there was a shout from the lounge room, and I had naturally assumed that Ed had dropped something on his foot or hammered his finger or whatever. So I came running into the room. When I came running into the room, this was on the TV. So this was the opening ceremony of the Rio Olympics in 2016, and Ed Hawkins' climate spiral was being shown to however many people it was, 1 billion people, 2 billion people, whoever it was that tuned in to the opening ceremony of the Olympics. We had no idea that it was being picked up. So this is one of the magical things about data visualization. You genuinely have no idea where it's going to go and how it's going to be used, but you really hope that you've invested the effort in the first place to ensure that the message is as clear as possible. So of course, 2 years on, and everyone is intimately familiar with the climate stripes. And here are just some examples. Yesterday for World Environment Day, a group of climate activists in Italy managed to get it on the front page of the La Repubblica newspaper, and they had a meeting with the Pope. So they showed this to the Pope. They gave him a climate stripe scarf. So again, this is one of those data visualizations that keeps on giving, because it's a very simple message. And it keeps being updated, and it's available at that local scale, so people can go and look at their personal location and understand the change in their location. So the figure that I skipped over is one of my favorites, and this is a polar projection. I really like small multiples to give that context that Scott was talking about, to give that historical context of, yes, the Arctic has always had high variability, but if you really look at the changes over the last 50 years or so, 70 years, you can see how much warmer we are now than we were 30, 50 years ago. Now, in terms of the Copernicus Climate Change Service, so we're one of the 6 Copernicus services that are funded by the European Union. And I think I can speak for all of us at C3S and ECMWF that we fundamentally love our jobs, because we get to provide open access data for society's benefit. And many of my days are spent either interacting with users of our data or attempting to find ways to simplify how people can access our data. So we have the climate data store. I think one of my colleagues is online to provide links in the chat. And through the climate data store, you can access, I think these are old numbers now, over 140 data sets, which includes ERA 5. So that was one of the data sets that Scott uses. And the way we really like to think about C3S as a service is that we're effectively converting petabytes of data into kilobytes of information for society. And we really do this by combining observations from the air, from the sea, from the land, anywhere we can get. So we're combining satellite information with in situ information, with models, and enabling society to plot that data themselves. Another thing that I really like to show, and a big part of our program, is leveraging those satellite observations. So here you can see the Global Climate Observing System, and they've defined that there are 54 essential climate variables that make up our Earth system. So within C3S, we have 22 ECVs available through satellite data, and then a further 8 to 10 that are available through reanalysis data. So you can see just by going to one location on the internet, you can get approximately half the variables and the majority of ones that can be observed by satellite in one location. Obviously, there's challenges with changes in satellite acquisition. So it's improving all the time, and we work very closely with EUMETSAT and with ESA to ensure that we can take what has been done in terms of research and development and turn it into an operational product that people can use for free. So another big part of my work at ECMWF is the climate monitoring side of things. So we monitor the climate on a regular basis. Our monthly bulletin will be published tomorrow. And for everyone's information, it was also the second warmest May on record globally. So for 2023, we've had, I think every single month this year has been in the top 10, if not the top 5 for warmest month since 1950. So the European State of the Climate Report is a significant community effort that's published on Earth Day, so the 22nd of April or thereabouts every year. And it's really an assessment of the state of Europe particularly, but we also cover the global indicators. And so we're mandated to do this. We've agreed with the European Commission that we'll publish this report each year. And where we differ from the WMO State of the Climate Report and the BAM State of the Climate Report is we really invest in the data visualization to really ensure that the graphics that are used in the report are as compelling as they can possibly be. And sometimes we get it right, and sometimes it's very much a work in progress, and there's more to learn. So in terms of how our climate is changing, we also have a relatively new climate indicator dashboard. And you can really see that this is one of those context pieces of information. Globally, we're at 1.2 degrees above the pre-industrial average, but Europe is warming at twice the rate of the global average, mainly because we've got more land area, we're closer to the Arctic, which is warming even faster. The Arctic is warming at about 3 times the global average. But this is also a place that you can check greenhouse gas measures, cryosphere measures, and really look at climate indicators and how they are changing. And we update this annually. One of the other things that's really important is to show our data alongside other data sets. So when we talk about these long-term trends, we really compare our data with Vecoli Earth, with NOAA and NASA, with the Met officers, HAD Crew 5T data set to really ensure to people who are unfamiliar with climate data that all of these data sets are saying the same thing. So, maybe you're skeptical about modeled products that are gridded, and maybe you're skeptical about observations, but when all of these different types of data sets say the same thing, to any scientist, the answer is overwhelmingly compelling. This again is another example of small multiples, and it's really a nice example of how variable 2022 was. We had heat waves throughout the year. We did have some cold spells, as Scott mentioned, less in Europe, but you can see a few on this slide. But overwhelmingly, we had more warm periods and heat waves in 2022 than cold waves. And this, of course, led to the implications for the significant drought that we saw in 2022, because we had a very dry winter with very low snowfall, a very dry spring as well. So we didn't have that recharge last year. When we look at the role of different graphics, here we show how different summer has become. So 2022 was the warmest summer on record for Europe, and it beat the previous year, which was actually set in 2021 by 0.3, 0.4 of a degree. So in terms of a record margin, close to half a degree is a huge amount. The other thing that we cover is key events. And as Scott said, you know, it's important not to focus on one member of those extremes, but to cover both. So as an example, you know, in February, and it's one of those really challenging things to do in the context of a map, but in February last year, we had 3 named storms in 1 week. And that's really unusual weather behavior. But then we had these heat waves, marine heat waves, the second largest wildfire event area on record. So, and you can see the records are pulled out on the left-hand side, but then we've got these icons to try and show where these weather events happened. This is the second year that we've done this. So if people have feedback on how we could illustrate this more clearly, I very much welcome people's feedback and input. One of the other things that we have found is really important to not just talk about climate variables, because they can feel quite, I guess, remote to people. So one of the key takeaways for me for 2022 was that European citizens were under more heat stress than ever before. So because it was the hottest summer on record, we know that severe heat and extreme heat were higher in Europe last year than they have been in the past. So really articulating the impacts for humans. So it's not just about temperature records, it's also about humidity, radiation, soil moisture, wind speed, all of these combine to impact how we feel the environment around us. And this is probably my favorite data visualization that we had in the report last year. And it was really tricky to come up with. I tested it with Ed and he was like, oh yeah, I'm not sure, but I think within the team we really liked it. So the amount of glacier loss in the European Alps last year was really extraordinary. It was about 4 times the year before, and it was more loss in a single year than we've ever seen in the European Alps glacier records. So if we imagine an ice cube about 5 kilometers cubed, if we put that ice cube in central Paris, this ice cube would tower over 5 times the height of the Eiffel Tower. I'm in Brussels this week for meetings, so I've made the equivalent for Brussels. There's the atomium. The atomium is about 100 meters high. So the ice cube next to the atomium would be about 15 to 17 times higher than the atomium. So just imagine that volume of ice being lost in a single year, and the implications then that we have for the communities and society that rely on the water and the snowmelt from those glaciers. One of the final ones I wanted to mention, and this gets to the animation side of things, is we saw this extraordinary heat wave in Greenland in September, where I think it was 23 or 24% of the surface of the ice sheet melted, and there's a fantastic sentinel image where you can see those melt ponds on the surface of the ice sheet. And this is well, it's due to the heat wave, but also we're seeing more atmospheric rivers. So the animation on the left hand side is showing you the animation of these atmospheric rivers that are coming out towards Greenland. And we know from our data records that there are more atmospheric rivers hitting these high latitudes than there has been in the past. The last one that I wanted to show, again, it's to try and give this context, and I'm not sure we've really landed this. So again, if people have ideas of how we could show it differently, I very much welcome it. So this is the total mass loss of ice sheets in Greenland and Antarctica for the last 50 years. And it's 11,000 kilometers cubed, and the disk is effectively 1 meter high. So if you can imagine, all of the European land area, more or less, can be covered by what we've lost from these polar ice sheets. And it's again trying to give this context of 11,000 kilometers cubed. What does that mean to people? How do we show it in a way that's meaningful so that people can go, wow, that is a lot, that is a problem. I need to change my behavior. I need to have conversations about this so that other people are aware of the problem that's coming down the road for us. I think one of the other things that I'd like to talk about is ERA 5 is our global reanalysis product. It's our maps without gaps. It's a 30-kilometer gridded product that's back to 1940. It's available near real time, which is why a lot of people like Scott, who are very active on social media, use it to show extreme events. But one of the things that we find really challenging is to really visualize how reanalysis can be used. The reality is it almost has no boundaries. So, you know, all of the machine learning weather models have been trained on ERA 5 because it's free and open. But so we can reconstruct historical storms, we can show maps, but really to show the value of this enormous data set, it's something that we're still struggling with. So the best option that I've come up with, and again, I welcome the thoughts in the comments, is on the left is, of course, the incredibly famous photo of the Earth from one of the Apollo missions in 1972. And on the right is the recreation from ERA 5 of the planet on that day. And you can see we've got a lot of the features close in terms of the cloud structures that you can see. We're not there yet. And this is one of the really exciting developments with ERA 6, which would be even higher resolution, a partially coupled system. So again, we're getting closer and closer to being able to go to, you know, any time we have a photo of the planet to recreate what was seen on that day with our reanalysis. So that's all I had. Thank you so much for listening. One final point that I'd like to say is we're about to advertise for a data visualizer on the ECMWF jobs. So if you're interested in applying or know anyone who may be interested in applying, then please be in touch with me or be in touch with us through social media and keep an eye out for that. Thank you.
Thank you very much indeed, Sam. Thank you so much. We'll have a bit of time for questions after Chris has spoken, but one question if it's okay. So I think when I've seen you, I saw a photograph of you at the European State of Climate launch and you were wearing the stripes. Were you wearing the stripes?
I can't remember. I wear them quite often. I was wearing them yesterday when I presented at the European Parliament to the MV committee, and I wore them at COP26.
And so the question, I guess my question is actually, I mean, there's something, it's really cool, but there's also something quite personal, that the clothes I choose to wear are quite a personal choice. So what's that like for you, wearing the stripe, wearing your science?
So in COP26, I hated it, mainly because COP26 in Glasgow was after 2 years of working from home. And then suddenly I was in a conference in Mars with 20,000 people. And that, and I think that the preceding 2 years had shifted me on the introvert scale, right? Because there were just no crowds. So I and Ed's climate stripes have inspired a huge number of artists around the world. And one of those is a fashion designer who did a whole capsule wardrobe. So she asked if I would wear her designer clothing at COP. So I did so. But it was really confronting initially. But it was great because people were coming out to me to ask questions about the stripes, ask where they could get the fabric, ask why I was wearing it, ask about the data. So it's a fantastic opportunity to start those conversations. But you've got to be on, feeling brave that day to be able to smile and engage and reflect on people's curiosity. And you've got to have that bandwidth. So. And I'm not sure I was mentally prepared for that in Glasgow, but I am now. So it was a bit of a baptism of fire, and it has been fantastic. And it is really great. Like, I was at a cafe yesterday, and the person giving me my coffee was like, "Are you wearing the climate stripes?" And I was like, "Yeah, I am." Cool. How do you know about them? And it's just a fantastic conversation starter.
Lovely. Thank you so much. And thank you for the rest of your talk as well. But we'll have a chance for questions, so do keep asking questions in the Slido, please. But we turn over to, you will have seen Chris Stewart in the chat rather beautifully, as Sam went through, posting all of the links to the resources. Thanks for doing that, Chris, because that means that people can have a look straight away at the thing. But yes, so Chris, I think you're going to take a more practical look at data access and C3S and the openness that Samatha was talking about. Over to you, Chris.
Great. Thanks a lot, Mark. So I have to say that the credit for those links comes mainly from Nuria. So she's been in the background, finding the correct links to the various different pages. So credit really goes to her. So it's very hard to compete with the incredibly inspirational talks so far from Scott and Sam. So I've decided that I won't compete with a presentation. Instead, I'm going to give a live demo, which is always fraught with risks and danger. But if you get it right, it's all the more compelling. So without further ado, I'm going to share my screen and I'm going to show you some things. Can you see my screen?
Yes, we can see the C3S website, so I can see your tabs.
Great. Okay, so this is where we're going to start. Now, I'm not going to, in the 10 minutes that I have, I'm not going to jump from one link to the next and show you, the various different pages, which already we have posted in the chat. But what I will do is I'm going to focus on two things in particular. So one is the climate data store, which is an absolute goldmine of climate data for those who want to do storytelling, analysis, visualizations. I'm also going to show the link to our educational resources, where you can learn how to access the data and integrate them into your workflows, whatever you want to do with the data. So starting from the homepage of C3S, if we just go to data, okay. So here you find a lot of various different links to the different service elements of C3S, but I would say one of the bedrocks of C3S is the data provided in the climate data store. So this is like a one-stop shop containing petabytes of climate data, and this is in different I would say, different formats and also different timescales. So we have data from the past, the present, and the future. From the past, we have what we call reanalysis data. So these are very nice data sets with observations integrated with state-of-the-art models to interpolate the gaps in space and time and give you a consistent data set from the past decades, which is excellent for climate analysis. We also have data from the future at different timescales, seasonal forecasts, and also projections into up until the end of the century. So to access this data, to find out more information about it, you just click on search here, and here you have a long list, okay, which is initially a little bit daunting. It's not particularly structured. You just have a very long list of data. Now, to make sense of this, you have a filtering system here. You can filter by product type. So here you find observations, such as satellite observations, in situ observations. You have reanalysis data. So these are the observations integrated with the model. You have the future data sets. You can also filter by spatial coverage, temporal coverage, variable domain. Now, all I'm going to do here at this point is just to focus on one particular data set and just show you how it looks and what you can do with it. So you can also filter by keyword here. And the main, I would say that the data set one of the data sets we are most proud of is our reanalysis data. So this is really an excellent resource for storytelling. It comes in a gridded format. There are no gaps. You can really do very good analysis on high quality data, climate data from the past. So if we have a quick look at this data set, so for example, here we have many different, it's basically divided in different ways because it's such a huge data set that we have different catalog entries for the monthly averages, the hourly data, data on different pressure levels. So you have different heights in the atmosphere. You also have single levels. So if we just look at the ERA 5 hourly data on single levels from 1940 to present. So here we have climate data of various, very many different variables. And in the first page of this catalog entry, you see a long list of the different variables here. So this data contains basically global coverage of a huge number of climate variables. Then to access this data, you go to download data, and here you have a web form where you can specify exactly the subset that you want to extract. It doesn't make any sense to select everything because here we're dealing with petabytes of data and it's just too big to download in one go. So you would select a particular variable, a particular timescale. You can even select everything here, select all. Okay, maybe you're interested in the climatology of only a particular month or everything. Again, a particular day or all days. And you can do the same thing. You can select the data for the whole world or extract only a region of interest. Then you can select also the format. Now, once you've done that, you can download the data. To download the data, you would need to log in. So if we just log in here, it's a very simple registration. You just need to put your name, email, and a few very simple fields. And then you can download all the data you would like. So then if you click on submit form, it'll download it. Or if you click on show API request, here you can download the data programmatically. So if you don't want to always be clicking around a form, every time you want some data, you can put this into a script and loop through different timescales or different, variables, however you like to do it. And what I'm going to show you now, in the last few minutes I have remaining, are some educational resources that really show you how to access this data and how to process this data for different purposes. Because in the few minutes that I have, I cannot show you a very, detailed, let's say, tutorial on how to make the best use of this data. But what I can show you are the links to resources where you can, these are standalone resources that explain exactly how to do this. Now, we have here a catalog of Jupyter notebooks, but what I'm going to show you is how to find this catalog. So if you go back to the C3S homepage, so here we are back in the C3S homepage, and if we go to help and support, and then if we go to training, okay, here you find some nice educational resources that demonstrate how you can make the most of the data sets on the climate data store. And the most recent of these are our Jupyter notebooks. So these are resources, educational resources, but they're also templates that you can download, modify, adapt to your own workflows, and they're already ready to use. So you can take these, and you can run these scripts, and you can already obtain the data you'd like, and you can modify them as you wish. You don't actually need to install all the various different libraries and and all the dependencies to run these Jupyter notebooks. You can also select some of these free Jupyter Hub environments, free Jupyter environments where you can run them. And I'm just going to give you some examples here. So on the left-hand side of this catalog, you see a number of different Jupyter notebooks associated with the different data types. So we have the notebooks associated with the reanalysis data, those for climate projections, both the global climate projections and regional climate projections, so CNIP6 and Cordex. We have a number of resources on seasonal forecasting. Some others will be published soon. Also, tutorials on climate indices, bias correction, and then finally here we have a link to similar notebooks on the Copernicus Atmosphere Monitoring Service. So if we just look at one of these, this is a simple tutorial that shows you, it demonstrates climatologies, how to calculate climatologies, and how to calculate the anomalies with respect to a climatology. And it starts off with accessing data. Now, what I'm going to do is I'm going to demonstrate how you can run these without installing anything. So if we just click on one of these links here, such as open in Kaggle, what should happen, and I hope will happen, is that this should now open in the Kaggle environment. Okay, and then what you would have to do is actually log into Kaggle. I'm already logged into Kaggle, so so that step we are not going to do. But from here, you can simply run these different codes and run these different code blocks, and it will run this notebook. So you just have to literally click play in succession, and you'll be able to create some beautiful visualizations and do some analysis on these data sets. So this is taking some time because it's now starting up a session, and you see now it's downloading and installing the CDS API, which is the first library that we will use. So that has now done. Then that should be finished very soon. Okay, that's finished. Now we can run this to import the various different libraries. And then here you would put in your API key to access and it would look something like this. This is just a fictitious API key. And then if I run that, then it will put that into a variable. And I'm not going to continue, but basically you can just continue clicking through these cells. And what you would do is you would download some data, and you would perform some calculations, such as converting the data from 0 to 360 degrees to plus or minus 180 degrees. You can also then convert from Kelvin to Celsius. And then we would do some first visualizations of this data, and then calculate calculate the climatology and anomalies with reference to that climatology, and so on. So these are very nice standalone resources to show you how to get started with this data in a very simple way. So I would really encourage you to explore this, and also give us feedback if you have any questions, any suggestions or recommendations, or if you have any particular needs that you think should be addressed, then please let us know also. It'd be really great to hear from you. So finally, I will stop sharing, and we will put the link to these. We will put the link to these resources in the chat. There are actually several links that are now shared. So one is to our training page, and then the other one is to the Jupyter notebooks, which I just demonstrated. So yeah, so thank you very much. Just sharing these links now.
Thank you, Chris. Excellent. So if we turn to some of our questions, and on the Slido, but the first question, which I think gets to one of the first questions on the Slido, is about copyright and sharing stuff. So the Jupyter notebooks you've just shown, can I just use them?
You can just use them.
Can I modify them?
You can modify them. So they come under the. Can
I give them to my friends?
You can give them to your friends. You can do exactly what you want with them. Both for your own benefit or for commercial interest, whatever you'd like to do, you can do it. So there is a license associated with them. The license is Apache 2, which is a very permissive license. Yeah,
and so I know automatically when I look at that I can use it and share it and use it commercially and do derivatives from it. Obviously, I can't claim to be C3S because that would be rude, but I can be me and I can do all sorts of wonderful stuff, which is cool.
And please do.
The first question. So the first question, so do you have to go, this is also people who are preparing images to share on social media. I think it came up during Scott's presentation. Do you have to go through any copyright protocols before sharing data and information? Do you want to comment on that?
I'm sorry, is this a question for me or?
Well, I think it's a question for you and actually Sam, or I could answer it as well. Oh well, it's a bit rude when you're the moderator answering questions. Have we got Sam as well?
Yes.
Yeah. I mean, have you got any thoughts on? Because I know you'll you're
Yeah,
familiar
so
with the idea of sharing stuff. Hi there, Sam.
If it's Copernicus data, then no. But on the pages that Chris shared, there's documentation there associated with the data set. And on the documentation page, it will show you, it will give you information about what the license is and what the license conditions are. So for C3S, there are some data sets that we generate ourselves, either through C3S or ECMWF, but there are some data sets that we broker from other organizations like EUMETSAT. So the broker data sets may have slightly different licenses, but all of the information is available where you're downloading the data set. I think the best practice is to really look what others are doing. So if you're building on someone else's image, obviously tag them, let them know that you're inspired by their work and building upon it. And that's, you know, common sense, just like in a peer-reviewed publication, you cite other publications that have come before and you're building on their ideas. It's the same philosophy. And I think as long as you cite the people crediting it, if you're unsure about licensing, that gives you a bit of a get out clause as well, because then at least you're citing where you came across it.
And we're the same. We try to tag our data and images and stories with licenses so that people know how to reuse them. But it's not always the case. So the citing is always good. One thing we're very careful with is when we put stuff on our website, then we're very careful that we have explicit permission to use the image. But when we're retweeting things or amplifying somebody else's content on social media or linking to somebody else's website, that's okay. From us. So when will some more open data be available from ECMWF, such as soil moisture forecasts, evapotranspiration, etc.? Can either of you speak to that?
I think I'd refer to Sam. I don't know if you would like to answer that question.
We've lost.
I mean, there are new data sets coming all the time. So, you know, and we have already a very, I think Sam is speaking, I don't know.
Oh, go ahead, Sam. Right, I'll tell you what we'll do with this question, because it's very specific. What we'll do is, if it's okay, Chris, can you find the answer? And at some point, we'll make sure that everybody gets the answer to this question.
Yes, we'll do.
Brilliant. Yes. Okay, I believe that ERA 5 in the Copernicus data store has a resolution of 9 kilometers. Is there a plan to have a higher resolution data set in the future? Samantha's
Sam,
back.
do you want to answer that one?
Yeah, so I answered it in the chat. So ERA 5 is 31 kilometers, but ERA 5 land is 9 kilometers. There's also a Arctic pre-analysis, which is 2.5 kilometers, but it's only part of that Arctic domain at the moment. So we're extending it over the whole Arctic domain. ERA 6 will be higher resolution than ERA 5. At the moment, it's looking like it's going to be 14 kilometers. So significantly higher resolution than ERA 5. But ultimately, we're still in pre-production. So we're still doing the mathematical equations of how efficient our new supercomputer in Bologna is and how much we can afford to run without impacting other users of the supercomputer. So it will at least be 14 kilometers. I'm ambitious that we can maybe get down to 11, but that's a TBD. We'll know by late next year what the final resolution will be, and then it'll be launched in 2027.
Cool. Actually, I tell you what, let's maybe do rather than go through each question, because you can see them on your screen. Chris first, are there any of those questions you would like to answer straight away?
Yeah, there are a couple of questions. Like one is tutorials using R. So that we do get a lot of requests for tutorials using R, more so using Python, but there is also a significant R community. So this is something we're putting into the planning. I can't guarantee that we will do this or when we will do this, but it is definitely something that we're aware of. Just looking at some of the other questions. Don't know if maybe Sam wants to answer any of these data-related questions.
Yeah, sure. So again, I answered some in the chat. So there was a question about the European climate taxonomy and a climate risk assessment. And yes, we are contributing to a report that the European Environment Agency is leading on. So there's a big consortium of scientists that are working towards developing this very large report, and it'll be published next spring, I think. It's the spring 2024. On the glacier loss next to Eiffel Tower, we aren't planning on doing any other size ice cubes, but again, in the chat, I provided an answer, and that answer gives you a link to the webpage of the report that gives you the time series of the glacier mass loss. So you can download the time series, and then you could, if you wanted to, adapt the previous data for each year into an ice cube, but we won't do that directly. But anyone can download the data set and go from the time series to turn it into a cubic amount of ice loss. The question on dynamical downscaling software, Chris, I don't know if you're aware of anything. I'm not aware that that's something that C3S provides, but there's certainly other climate services downstream of us that work very much on dynamical downscaling. I don't know that it's a free service though. I think it would be a paid for service, but I would encourage this person to look at Eurofied land. They're interested in Jordan, and therefore they'd have the 9-kilometre resolution rather than the 31 kilometres of Eurofied Global. The question on the climate stripes, which came from the University of Reading. Yes, absolutely. And I neglected to mention that that's obviously where Professor Ed Hawkins works. The climate stripes aren't based on a climate model though, they are based on observational climate data. So there's obviously a lot of modelling products that do come out of the Department of Meteorology at the University of Reading, but this isn't what the climate stripes are based on. So hopefully that answers that person's question.
And so one of Ed Hawkins's other roles in the world, as well as the stripes, is getting hold of historical data and digitizing it, getting it digitized, yes. Which is
it's his favourite project in the world.
The more that we want to make certain statements about the world's climate and go back as far as possible, we need this. I'm a satellite person. I think satellites are amazing, but we, even in our world, recognise the value of the surface record and the ability to compare and make sure we're saying good things and true things really matters. But that's a separate thing. What we're going to have to do is cut this session short. Chris and Sam, if you can, to put replies in the Slido would be amazing. Thank you both for joining. And as Chris mentioned quite a few times during his talk, he was always saying, if you want help, get in touch, get in touch, get in touch. So my experience of C3S is they're very willing to help. Go to their website, look at their documentation and ask for help if you need it. Sam and Chris, thank you so much indeed. It is time now to turn to a more global perspective. So we turn to Clare Nullis from the World Meteorological Organization and looking at impactful communication on weather and climate with Earth observing data. Clare, welcome. Do we have you there?
Yes, I think you, can you hear me, everybody?
Yes, perfectly. Thank you very much. Over to you, please, Clare.
Okay, yes, so good afternoon, everybody. So my name is Clare Nullis. I work in the Strategic Communications Department at the World Meteorological Organization. And just to take you up on the last point about historical weather data, the World Meteorological Congress just met. It held its 2-week session, which it does every 4 years. And one of the resolutions passed during that session was, on the importance of the centennial weather stations, these long, the long time memory of us. So that was just as an aside. Right, so I'm now going to sort of make my presentation, hopefully, if I can share the screen, and it will obviously be focusing more on the global aspect. So I'm just going to try and share now.
So we see your slides in presenter mode.
In presenter mode, wait a minute, let me just...
Sorry, in edit mode. Yeah, there we go.
Okay, can you...
Brilliant.
Okay,
yes,
perfect.
we can.
Okay. We're in business. So my title has been given to me, Impactful Communication, Weather and Climate with Earth Observations Data. This first slide is just a very quick glance at the type of media coverage that we got last year. The green is broadcast, orange is social media, and the blue is the online media impacts. That's just the number of times that we get mentioned in the media. What it doesn't do is to measure the reach and say, you know, if we hit the Chinese media big time, which we do on a regular basis, you know, then we're talking about hundreds of millions of potential audience. You will see the spikes in that, and those spikes are normally when we issue a major report or when we get an extreme weather event. And this is one of our flagship reports, the State of the Global Climate Report. We issued the provisional report just ahead of the UN Climate Change Conference, so November, December. It's a very, very, very keenly awaited report. There's always a little bit of a media frenzy. The UN Secretary General, Antonio Guterres, you know, gets involved quite often. Head of the Climate Action Team and United Nations gets involved. And we usually launch this on the opening day of COP. We use 6 data sets in this report, and obviously the Copernicus data set is a very important one of these. This graph probably looks quite familiar to you by now. It's the temperature, you know, the temperature increase over the years based on the 6 data sets. And interestingly, I've noticed there's a real trend in the past couple of years. There's been a big upsurge in requests from journalists to have the raw data behind this graph. So it is showing that, you know, we're now getting the graphics departments of, you know, mainstream media, New York Times, the news agencies, you know, now wanting the raw data so they can create their own graphics. Another element of the State of the Climate Report is the global mean sea level, which unfortunately keeps breaking new records. And on this, we rely heavily on Mercator International. So, you know, it's very, very heavy reliance on input from Europe in our State of the Climate reports, which are really, you know, it's an international undertaking. And what we used to do in the past was talk about literally just the state of the climate. What we do now more and more is to talk about the impacts on displacement, on refugees, on food security, on the environment. And so we're really embracing now, you know, quite a wide number of partners in the United Nations family. But you know, our reports still basically, you know, rely very heavily on Earth observations data provided by you. And we get noticed, and your data gets noticed. So this was just a quick screenshot of the COP27 meeting last year with President Biden, who, you know, made a statement, and quite early on in that statement, you know, he name-checked WMO, which, you know, for us was quite an honor. Just quoting us as saying, the World Meteorological Organization said the past 8 years were the warmest on record. And we might as a community, we know that, you know, it's nothing new for us, but we need to sort of look at it from more of an outsider's perspective, and, you know, and realize that for them, yeah, wow, you know, past 8 years has been the warmest on record. Wow, that's quite something. So our reports do get picked up. Your data, which we use, does get picked up. This is just another example. Antonio Guterres relies a lot on WMO content, WMO reports for his speeches, for his social media content. We have a very, very close working relationship with his office in New York. And this was a report that we issued about a month ago. It was in conjunction with the Met Office, the Global Annual to Decadal Climate Update. And in that report, we said, you know, there is a 90% chance, obviously with El Nino kicking in now, that we will have a new warmest year on record. And we said, what got the headlines was, we said, you know, there's a 66% chance that one in the next 5 years will temporarily, and we keep stressing temporarily, will temporarily exceed 1.5 degrees. We rely, as I said, very, very heavily on Copernicus products for our social media, for our outreach, obviously for the technical content of our reports. This is just something that Mark Parrington tweeted a short while ago in relation to the fires which are happening in Canada. And I think what's interesting for you is that, you know, the fact that WMO sort of picks up a tweet or social media content from, you know, individual scientists or from individual agencies, it suddenly then gets in the eyes of the outside world, it gets the UN seal of approval. And so that means then that, you know, the likes of Mr. Guterres or the main, you know, United Nations social media accounts, they will then feel confident to use, you know, to use that information, whereas they wouldn't necessarily use it from an individual scientist, you know, from Scott Duncan, you know, great, you know, wonderful as his content is. But if we use, you know, material from Scott Duncan in one of our tweets or, you know, LinkedIn posts or Instagram posts, then, you know, the rest of the UN will, you know, will feel confident to pick that up. Another good example. This one is of India. You know, India had a bad heat wave. We obviously have to rely on the material provided by the India Meteorological Department. They are, you know, the authoritative source for India. Their graphics are not very good. You know, their website's not particularly user-friendly. So I was looking for something to illustrate it, and I thought, you know, I'll use the ECMWF data. Likewise, the slide on the right was when Spain, the Iberian Peninsula, North Africa had a very bad heat wave. Again, we use the Copernicus material there. Samatha spoke briefly, well, spoke at length actually about the state of the climate in Europe. So there are actually 2 iterations of this report. There's the Copernicus version, which comes out first, and then there is the joint Copernicus/WMO State of the Climate in Europe report. We did the first version of this last year in November. It was just ahead of COP, and we actually thought, well, you know, it's late in the year to be talking about 2021. People will be focusing on COP. We weren't expecting much media interest, and quite the opposite happened. We were, you know, really bowled over by the media interest, by the number of questions we got, by the ensuing coverage. And the bottom line that a lot of the media went with was, you know, Europe is the fastest warming of the 6 defined WMO regions. We saw that in headlines over and over again that Europe's heating much more than the global average. We are on the 19th of June releasing the second in the series of the State of the Climate for Europe, and so it will be the report for 2022. As Copernicus have said, summer 2022 was the hottest ever recorded. There was severe widespread drought, wildfires, heat-associated excess deaths, but we obviously don't want to just duplicate what Copernicus said in their report released for Earth Day. We want to take it one level further, and so in this forthcoming report, which will be released in Dublin, we're going to have a special focus on energy and how renewable energy in Europe is really increasing, but also looking at how weather and climate dependent renewable energy is, and so how we really do need to strengthen weather and climate services for the renewable sector. So that's just a very quick, brief snapshot of how Earth observations data, how Copernicus data really supports not just WMO, but the entire UN family. We think it's making a difference. Certainly, I'm in the media office. I get to deal with the media inquiries, and the level of inquiries that I'm dealing with, even when we don't have a report, it's probably twice as much as it was even a year ago. So your work matters. Keep at it. We're here to support you, and we thank you very much indeed for your support.
Thank you very much indeed, Claire. If it's okay, do save questions. What we'll do is we'll gather the questions for your talk, Antonio and Ivan, and then take questions at the end. So everyone is welcome to put their questions in about the state of reports and the work of WMO in climate communication into the Slido. But we move on to Antonio. Antonio Vecoli, are you there? Just to check. Yes, you are. Excellent. Hi, Antonio. Nice to see you again.
Hi.
So, Antonio, yeah, you're going to show us some examples, practical examples from your work of great visualization.
Yeah.
Over to you, please.
Yeah, I am Antonio Vecoli, and I'm currently supporting EUMETSAT in the exploitation and data access of the, let's say, same SAF data, and even more in general from, let's say, other SAFs data. And so my presentation will be mainly based on seeing this kind of data that haven't been shown so far. And so I'm going to share my screen now. Let's see if I can do it quickly.
So we see your slides, but in edit mode.
Yes, it should be now. Yeah.
And now we see the presentation. Wonderful.
Okay. So, well, I decided to start my presentation from this, let's say, wrapping up slide because we are on the fourth session of the workshops, and so far we have seen different kind of data, from satellite imagery to atmospherical data and marine data, and today we arrived in talking about weather and climate data. And before me, Scott Duncan made an amazing presentation about how to best use climate data for storytelling and for explaining climate events and let's say the science that is behind the climate images. On my side, I decided to highlight not on the, let's say, Copernicus, Copernicus the ECWF data that has been presented already by Chris, but a good starting point is anyway the European State of the Climate 2022, because in the link that I've posted, we can find different kind of data and variables that can be used for the European state of the climate. And among these variables, we can find a specific one that is the cloud and sunshine duration. And these kind of variables are actually provided and available from the Copernicus, from the climate monitoring staff of EUMETSAT. The Copernicus, the climate monitoring staff is a satellite application facility that is a center of excellence, one of the 7 center of excellence of EUMETSAT, and provides operational products for different environmental variables. For example, in this case, we see the sunshine duration that has been used for the European state of the climate. And the sunshine duration is not only important, let's say, for climate consequences of having more or less hours of sunshine on land, but it's important also, let's say, for consideration about the production of renewable energy. In this slide that has been used in this page of the European State of the Climate, you can see 2 different visualization usage of the sunshine duration data. So a sort of bar plot and an anomaly map. And this is something that can be actually done with this kind of data that are open and free and available for whoever wants to try to use this data. And as well as the same stuff data, the climate data EUMETSAT also provide other kind of variables that can be found on the land surface analysis stuff. And there are, for example, the LST or NDVI or other variables that are related to vegetation, or even the hydrology stuff that instead is more concerned about the precipitation, soil moisture, and even snow products. On my side, my current activity, I'm involved in developing Jupyter notebooks and training materials for CMSAF. And I have, let's say, been through, I've encountered different way of visualizing data from this CM stuff or from the other stuffs. For example, this is an example of a monthly anomaly map of soil moisture from the H stuff on April 2023, when we had with the first strong heat wave in continental Spain, and this map shows the let's say the strong negative anomaly concerning soil moisture that was affecting Spain on April. This is a sort of bar plot that is focused on the sunshine duration anomalies over Italy in May across the full time coverage of the sunshine duration product. It spans from 1983 to 2023, and we can see that especially for the latest bar that is related to May 2023, we had one of the lowest, most negative anomalies of sunshine duration for Italy, and that can be put in relation with the, let's say, very bad weather conditions that have affected Italy for the majority of the weeks during May 2023. This is another way to exploit the long-term data that are available from the same stuff and the other stuffs in general. This is the time series of monthly anomalies for over Italy, and show the anomalies, the variation, the anomalies for each month on the full time coverage of the product, and also show the linear trend that can be inferred from the anomalies. And we see that the sunshine duration is slightly increasing year by year over Italy. And this is instead the last one I'm going to show is, let's say, more technical and, let's say, less intuitive than the other 3. It's called a box plot, and shows the distribution of the values of the sunshine duration for each of the 12 years of the month of the year. And this kind of visualization can be found, can be provided with Jupyter notebooks that will be available soon in a new let's say platform that is cross-domain. It involves from atmospheric composition to weather, passing from climate, land, and the marine. And these Jupyter notebooks will be, let's say, readable, but also executable, and individually for each user that wants to log in and register. This is how the Jupyter notebooks will be presented in the platform. So there will be a sort of a catalog, and it will be possible to filter the Jupyter notebooks for platform, for sensors, or for even for the subtheme that will involve the Jupyter notebooks. I'm going now to show from the slide to pass to show how a notebook will be, the notebooks are organized. Let me see if I can do it quickly. Is it visible, or should I share again?
You're in present edit mode, so we can see you, but you're in edit mode.
You cannot see it. Let me see. I try to share again. Sorry.
Okay.
Let me see. Yeah. Let me see here. Okay.
Now we see it.
Okay.
Now we see it.
Yeah. So notebooks will be organized in different ways. There will be notebooks trying to guide the user into the production of the maps and explaining the steps, the technical steps that has to be executed to do it. And this is one of the examples, and can produce anomalies calculation not only monthly, and as we have seen in many examples, but also annual or seasonal. So with different taking different temporal coverages. So when we go to the through the notebook, we are guided into the data preparation, and it means that the data are already available in the Jupyter environment that the user is going to open. He shouldn't download anything from a site, and he can prepare the data, so pre-process the data in order to have them properly stacked and ready to be used. Here there is the possibility also to see how it is possible to cut the data to create a subset of the data. In this case, we are going to cut, let's say, all the land on the full globe to get only the lands from the globe. Here are the different steps that are described carefully, and on the other on the part of the steps, the calculation of the anomaly are explained with the different operations.
Okay.
Yeah.
Okay.
You see the visualizations of the for example, the annual anomaly for the 2019, and then we move to see how it is possible to derive the seasonal anomalies for the same for the same product, for the sunshine duration. How it is possible to visualize them, to visualize it, and how it is possible to derive the monthly anomaly again for the product. So we go from annual to monthly. And again, how to visualize this kind of data. Then we see how to produce the box plot for the climatology that goes from 1983 to 2021. And this is, let's say, a more didactical notebook. It is important to say that the notebooks are, let's say, supported with a specific functions notebook that provides easy function that can be used even for the user that cannot code himself the full process to obtain, to extract the anomalies and other indicators. And from this kind of notebook that is more didactical, so made to for the user to understand how to produce the data. Here we have a notebook that can show instead a series of more graphical results. So starting from the data preparation, that is an obliged step. Here we work on the polygon that takes Italy and analyze Italy. We go from the anomaly calculation, and here this is the first result we have: the sunshine duration, the monthly anomalies over Italy with a linear trend. Then with the furthest steps, we obtain the bar plot that is especially for the month of May until the month of May 2023 with this quite strong negative anomaly. And again, here we produce instead the monthly anomaly map for the full Europe. And in this case, it is important to say that when we produce an anomaly map, it is very important to choose the proper color map, the proper palette. Usually, an anomaly map should be visualized with a divergent palette, and generally, let's say the area with no variation should be depicted with white, so that we immediately see which are the regions that have not been affected by any kind of anomaly during the considered period. And again, here instead, I show a different product taken from the HSAF. It was the one that it was a minor size on the previous slide. This is the anomaly of soil wetness index, so a sort of an easy version of the soil moisture, and it depicts the situation of the soil moisture on April 2023. And it is visible that I changed the palette, the color map, to make more intuitive that we are talking about land and not about, let's say, temperature or radiations. And of course, I choose to depict in red the negative anomalies, because in this case, they are not only negative because of the -0, but because also it's, let's say, not a good effect, this kind of negative anomaly for the soil moisture. And we can see the difficult situation that was in Spain and in northern Italy, and also the strong episode of drought and heat wave that affected northern Africa. And at the end, I also used one product from the Landsaf. This is the leaf area index, so it concerns vegetation, and it is taken from May 2023, and you can see that Italy and even part of Spain in May 2023, let's say, it was not affected from a complete bad situation, and especially for Italy, that was due to the strong episode of rain that and even floods that affected northern Italy, and especially on the eastern coast. There is to say that all the three SAFs that I have shown, so LSA, HSAF, and CMSAF, have their own his own website, and the website is has been posted on the slides, and they should be also appear on the chat. Each SAF can be accessed by the user with a with its own registration, and let's say the data can be processed even for the other SAFs once that we have downloaded them in a similar way from what is done in these notebooks for the data of the same SAF. But at the moment, we are also working on a way to, let's say, homogenize the access to this kind of data from different SAFs, and even with the approach of a data cube approach. And we are trying to make this approach stable and functioning, and it will be, let's say, put in a, let's say, published as soon as this will be completed, and it will be for example, considering different products that can affect, that can show aspects of drought and vegetation, and they'll be taken from the different apps and even from outer data providers that are not included in the SAF. And so this is the, let's say, the practical examples I wanted to show about the SAF data. And as a final slide, I tried to summarize some. Let's see if I can show it again here. And share it. Yes. Yeah, and register in presentation mode. Okay, so few tips for a good data visualization. When we talk about the climate data, it is important to choose an appropriate color map, and it should be intuitive. So trying to facilitate the visual interpretation of the data, and in general, we should avoid rainbow color map. We should try to figure out which is the best for the data we are using. As I said, to choose a divergent palette when we use data for anomaly maps. And also, it is important that when we produce an anomaly map and we visualize it, the map should report even the reference period that is considered, because different reference periods can lead to different features on an anomaly map. And also, this is quite a practical tip. In the notebooks, there is the possibility to change the maximum and the minimum values in the color bar, and that helps to, let's say, highlight the features that are in a map, because if the range is too large, we risk to, let's say, to lose some features, some patterns that is in the map. If it is too strict, everything will be, let's say, highlighted, and it is possible to understand what is really happening on the map. While for the plots, as we have to do with a long time series, it is important to let's say, to facilitate the reading of the maps of the plot. And if we talk with we work with the monthly anomalies, when we have a large temporal coverage, it is advisable to put years on the x-axis in order to properly see which is the year on a specific point. And if we use a bar plot with the time series with a color, what we call a color map of a divergent one, and we should use the same color bar that is used for an anomaly map of the same variable. And of course, even for the plot, it is always good to put on the axis the units of measurement, because so we say we are scientifically aware of what we are talking about. And that's all from me at the moment.
All right, excellent. Thank you so much, Antonio. And do stay around for questions, and people who have questions, do drop them in the Slido and upvote the questions in there, because we'll start from the top of the prioritized questions and work down. Thanks, Antonio. Our last speaker for today is Ivan Smiljanic, who is one of EUMETSAT's weather application experts. Hey, Ivan. Hey, great to see you. Do we hear you? We don't hear you.
Is it fine now?
Now I hear you.
Okay, good.
Excellent. Yes, so Ivan, you're one of, I guess internally we would describe you as one of our most knowledgeable geeks on the application of weather satellite data for weather forecasting. And so it's great to have you here, and over to you.
Thank you, Mark. And I was kind of thinking I'm going to hear the geek word, but it comes as handy because hope you can see my screen. Let me know if not. Because from being geek to you see here we're using also Twitter as a mean of communication, it's hard to balance between being very simple as a beginning session or presentation show from Scott to be very specific about the data. Well, but I'm going to try to cover at least the bits about the data. So basically, conceptually, what kind of data do we have, and how quickly to see the data and visualize. So what do we do at EUMETSAT training, or the USC User Service and Climate Division? We do a lot of trainings, obviously. We talk to users. We try to understand which of the screens are showing what and how to complement what they're doing with our data. We talk to the scientists. We do pixel-based analysis, so to say. And we, of course, communicate through social media to the rest of the world, be it my grandmother or whoever. So it's a wide range of users that we try to serve, and we try to do it best. But what kind of satellite data is there? I guess you're noticing this is a joke. There's plenty. No one can name everything. But let's start from basics, just to discriminate between, okay, geodata. So geostationary satellites, they orbit far away from the Earth, so 36,000 kilometers. So they can see a whole bunch of the Earth. And what is good about them is, yes, there's a wide, comprehensive view about the Earth. They can scan every 5 minutes, even up to 2.5 minutes. So they can track hourly, diurnal, or in this case of this animation, this is seasonal changes across the globe. We can track weather step by step with these kind of satellites. There are different viewing angles, not only for the satellite, but also for the sun. Sun is moving from east to west in this view. And we can utilize this, for instance, for better aerosol detection. We can peek behind the clouds. We cannot really peek behind the clouds, but the clouds are moving. So if we're interested in the vegetation cover, we have an overpass, so to say, every 15 minutes. So the cloud may move and we may see if the ground is bare or vegetated. And of course, it's a quick look. If someone asks me what is the weather in half an hour, I'm gonna look at this data and see where the clouds are, and quickly I'm gonna get the assessment. Unlike the geostationary satellites, low Earth orbit satellites, they're very close to the Earth. They're spinning around very closely. Hence, the coverage is very bad. Twice or a few times per day, they cover one area, but they are very close, so they get the detailed view, like this Sentinel image over the Alps. They have more useful instruments because they're closer. They get more energy from the Earth, and then you could utilize more sophisticated instruments like radars. They can track still seasonal changes, of course, and they also have these viewing angles as they fly by or over the feature. They see it from different angles. They can actually peek through the clouds in microwave or active radars. And some of the polar orbiters, they have direct acquisition as they fly over the user. They can dump the data. So that's pretty cool. And EUMETSAT has the fleet of geostationary satellites and the fleet of polar orbiting satellites with their instruments. But also, EUMETSAT operates Copernicus satellites. For now, I think it's only 3 and 6, but more to come, 4 and 5, for instance, atmospheric composition and a few others. And this synergy is not crucial only for the operational sense to exchange knowledge and experience, but also for the users. So, for instance, if you look at this case, someone mentioned drought in Spain. This spring led to a first major fire already in March, and we were testing the view of the new bird of MEEO with the instrument FCI with the Sentinels. On the right-hand side, we are kind of having the view from the LEO instrument about how our satellites, upcoming missions will look at this scene compared on the left-hand side to what we presently have. exaggerate a bit, but you see the difference and the use of it. Okay, so what happens when the event, be it tropical cyclone or the fire, major fire, flood, unfolds? What do we do then? What's next is, of course, inner me cannot wait to jump on the data, but with years I learned to recognize that the events are taken into a context, depending on the audience, urgency, complexity, domain. If it's far north, you have to use the LEO data availability. If it's readily available, you have to wait. Means of communication, is it Twitter or a study or a conference talk. Of course, then once you solve that, you can open your data software, like this very cool SIFT tool is, or you can open your notebooks, but you have to order data, of course. You can use some of the services that we offer together with partners, but there is a very nice couple of platforms that take care of the imagery itself, rendered imagery they offer, one of which is EUMETView. So EUMETView, I'm not brave as a previous presenter on doing the live demo, just so I don't go into details. I came up with a couple of slides just to give you the flavor, but I'm highlighting up there the storytelling hashtag, because I'm going to tell you a story. A couple of weeks ago, I was planning here in Southeastern Europe, I was planning a nice outdoor activity in the morning with the family, and also in the north, from Germany, I've talked to my colleague a few days later. He said, yeah, we were having a wonderful forecast for the morning and the next days, but there were clouds still hanging up there. It happened to me as well. That was the forecast bust, and I was interested to see what happened. So I used the EUMETView, and you'll see how. So EUMETView, like many others, they have layers, they have time regulation, you can export your imagery, etc. And if you open the new layer, you get the few categories. First is geostationary data, second one is polar orbiting, third one is geostationary, but it's from all the agencies around the globe. We'll see about that. And Sentinel data, as I've said. Once you open one of it, and I open MSG 0 degree, you have three categories. One is channels, pure spectral channels, normally in grayscale. Visualized products like cloud top height or chlorophyll concentration or rainfall rate. And then you have a bunch of colorful but also useful RGB composites, and I'll start with that. So the first one is, take it simple, especially if you're going for Twitter or light media communication. Natural color enhanced RGB is the first one that showed us the view on that morning. Actually, it was 12 local already. And you can see that in the area that I was showing in Southeastern Europe, there are indeed clouds. Absolutely no clouds were forecasted. And of course, you see the whole system. Likely there's low pressure area, but we'll see about that. Otherwise, it's green, and the grass follows the spring. Then, from a very simple view, which was the grass is green, the clouds are white, we jump into very complex, and this is the microphysics RGB. So now you're stepping out of the regular audience, web audience, to maybe more forecasting office or science, and you're getting the flavor of the clouds. Are they very high? What is the particle size? Are they water or ice phase? And immediately I see that I need another expert, and it's becoming even worse. I have to switch to convection RGB, which tells me the microphysics of the very top of the clouds. And finally, here I see that these clouds are too bright, orange or even yellow. Then they should be pretty red covered, like these cells over Romania. So I'm getting the clue that there are this cloud is polluted. The cloud system itself is very much polluted with aerosols. In this time of year, it's normal that the dust from Sahara is picked up by the low pressure systems. So I moved towards the south, 10 UTC still, I'm using the dust RGB, and the dust RGB is complex, but the dust is very much sticking out in a very typical magenta color. So if you have these shades of magenta coming into a system, it's like a band of clouds in the so-called warm conveyor belt being picked up and brought into the system, changing the microphysics of the clouds. And these clouds then became much more persistent than they were forecasted as the pure water clouds, so to say. Of course, it's very much appealing when you zoom in with a higher resolution data, and you're seeing very typical appearance of these clouds, the so-called DIBS clouds, dust-infused baroclinic cloud systems, with the cumuliform high clouds in bluish, and you see the low clouds. And these are the clouds that spoiled my day, basically. And you will see in animation later on how the thing evolved. The clouds over Serbia here, they are the same low clouds as over Slovenia, Croatia, parts of Bosnia and Herzegovina, but they're covered with these DIBS clouds, so they didn't dissolve early enough. And you will see the ones that are not covered, they are dissolved, and likely the forecast was pretty good. So I'm jumping onto the animation. Of course, through this EUMET view, you can easily choose the time range. You can run the animation directly, or you can order it to be downloaded and continue with your work. So what I did, I downloaded the data, and then I just put it into my presentation here, and you can see the development of this system, the warm conveyor belt bringing the dust over the Mediterranean, and the DIBS cloud is stretching far to the north. So that's the plot, and this is the reason why we had the forecast bust. Of course, if you want to enhance your yellowish high resolution image, you can do a little bit of overlay with transparency, and then you get the greenish from the vegetation. So the best from the both worlds, or you can stack the polar orbiting data in a very appealing true color RGB and compare this to Severi. And the message is very clear here. I won't go into details. I mentioned the GeoRing. We have the GeoRing data from the other agencies like NOAA, JAXA, and together we're compiling this in a nice ring view. I've changed to the North polar projection, and it's quite nice that you can see the weather systems around the globe like that. That leads me to another nice thing we do internally, just for the curious users. We do Year of Weather, and it's online. It's on YouTube. I think this one narrated by Mark. So we try to cover all the storm systems around the world, and the major events and the weather systems that occur globally. So no weather can escape the view here. So I have to remind myself about this, because likely we're biased looking at all this satellite data, we're biased to forgetting about the other data. But for instance, for the forecasters and other users, they care about other data. Another platform very handy for that is EUMETRAIN's ePort. There are two versions, JavaScript and Pro. I'll show the both case quickly. How they look like, they contain, on the right-hand side, you have the observation of the satellites, and on the left-hand side, you have the model field. So you can overlay, for instance, geopotential field, and you can lock on your low-pressure system fairly quickly, or you can change it quickly just clicking off and on the buttons into isotox locking on the jet streams, or you're interested in the synop station or radar data. So it's very easy and straightforward. ePort Pro looks like this. Again, it's the same principle, similar to EUMETView. Has a menu, you can choose layers, and it's more comprehensive. So here I'm looking at the infrared image simulated from the model. So this is what model was saying infrared should look like on the day that we had the forecast bust, and you can easily compare this to reality seen by Meteosat, and obviously you see that the forecast, the model itself was completely wrong. You can choose some of the products to verify what you're seeing. So this is cloud top height product. In blue shades, you have the highest of the clouds, and the white is probably the model is not sure, because there was some discrepancy between the model and the satellite data. And this product is based on both. And for the last view, this is the morning view through Adaguk viewer. That's a viewer produced by EUMET. They produce the data running the nowcasting software, and they display in this so-called Adaguk viewer. And what you're seeing here is a rapid developing thunderstorm product from this morning, looking on some of the storms. So fairly easily you can do a little bit of nowcasting. The color shaded total precipitate water, kind of like a fuel for the convective systems. And of course, you can choose your layers, you can change projections or base maps, etc. So with that, I'm going to finish the quick view. Of course, you can go to a web. There are many other viewers, but these are the ones I use fairly quickly. I'll finish with this slide. That was one of the first sessions. Jonathan Amos, journalist from BBC, had the summary slide like this: how to communicate your data. And I'm very much in agreement with Amos, with Jonathan. And I'm highlighting here: find a friend or expert. It's becoming more useful and more fun to to analyze the satellite data and enjoy the beauty of it. I leave here the link. If I missed any of the major points, you can come back to me or the training team at EUMETSAT. Thank you.
Thank you very much, Ivan. Thank you. That was great. We've hit our time, but what we'll do is we'll maybe take a few questions and see if any of the speakers want to leave a final thought. So if we could have our speakers as well. And maybe if we let each of the speakers take one or two questions of their choice, that might be a good way to start. Yeah, so do we have the speakers? I guess we could. Can we have the speakers on the screen as well, so we can see them? Everyone's got their camera on. Excellent. Ivan, seeing as you're here first, you get to choose first. Are there any other questions that you see that you would like to have a crack at answering, and any final comment you would like to make?
Well, I agree with the first statement. Simplicity is twofold. Yes, and this is what I was aiming at. I myself, in my daily work, cannot serve two masters, so to say. You have to choose what is your approach, and there is no black and white recipe to how to do that. It definitely depends on many different aspects that I showed before. It can be dangerous, it can be powerful, but it takes time. It takes time to make a simple statement as much as it takes time to realize that the simple statement is needed. So I'm going to leave it with that.
Brilliant. Thank you so much, Ivan. Antonio, do you want any questions that you want to take?
I saw a person asking about the resolution of the soil moisture product from the HSAF.
Yep.
If I'm not wrong.
Yeah, okay. Yes, there it is.
Yeah, so it's 10 kilometers.
And did you have, there was a couple of questions there about, what sort of software to work with. Basically, I think it's, do I learn Jupyter, Python, or R? What do you think?
Yeah, well, besides the Jupyter approach, so with Python, I have to say that, for example, for CMSAF, there is the R toolbox that enables people to work with R, and it is a software made in R, but people don't have to code and to write any line of code. It is basically a toolbox, and they have just to download the data, and the toolbox will provide the option to provide anomaly maps, plots, and even more processing of the data. So for people who are not interested in Python, they can get attention with the R option, and I can even provide the link if it can be useful. So it's one option more to work with the SAF data.
Okay, thanks, Antonio. And Claire, so last word over to you. Any other questions you would like to answer, or any last thoughts you'd like to leave us with?
There was a question on, you know, how to make sort of global impacts relevant to, you know, to people at local level, and that is one of you know, the challenges which we do face. And obviously, you know, storytelling and data visualization in that is really important. But certainly from the WMO perspective, you know, we are seeing that there is a huge upsurge in interest, in concern, in relevance, and you know, and data viz, as we've all seen, you know, with Ed Hawkins, you know, data viz is such a powerful tool.
Awesome, thank you very much. Now, there's loads of questions that we haven't had time to answer now. So what we'll do is a couple of things. One is we'll see if some of our experts can answer some of the questions in the Slido. So do maybe come back to the Slido tomorrow, see if your question's been answered, and see if there are other ways that we can get the answers out to you. Some of that will appear in the good practice guide that summarizes all of the information that we're gathering during the course of this workshop. So if your question hasn't been answered today, we have not lost it. It will still be there, and we'll come back to you. I'd like to thank all of our speakers, the second session speakers are Ivan, Claire and Antonio, as well as the people who had first time around, so Scott, Chris and Samantha as well. Thank you so much for sharing your expertise. We gather together the next Tuesday for the next session of the workshop, where we'll be looking at climate extremes. And thank you to all of you who have joined us. Thank you for your questions, and thank you for taking part. And I wish you a good rest of your day. Thank you very much indeed.
Thank you.